What is an in-range failure? You know, whenever you've got a computer that's set to see, to flag a code, if it goes above or below a certain threshold, then that's going to basically throw you some kind of a code, right? But what if it stays within the threshold, but it's still not telling the truth? That'd be an in-range failure, wouldn't it? All right. So, 1996 Mazda 626, 2-liter engine, C40 e-Transaxle, 122,653 miles. This car right here, this was the car right here. And we're going to make the assertion that any technician that's worth his salt will finish what he starts. Right? That's whether you're working on power windows, whether you put an engine in an HHR, whether you put a transmission back in a Suburban, or put a starter back on, or something like that. Even if you hurt your pinky, you'll still stay and finish the job. Right? And there were a few people in my 40-plus year tenure in this business that said they really enjoyed working on cars, but if the job got too tough, they called for somebody to either help them or finish the job for them. And they would say, I can't. You know, this kind of thing. I can't is a bad word. Right? All right, for fuel emissions, just they had an engine replaced in this one. And ignition systems got more complicated. It seemed like for a while, more and more customers would come to us and begin their story with, I had an engine replaced and, you know, we even had some yesterday we were talking about that were like that. Put a motor in it and all that. Don't get me wrong, most of the shops nowadays do really good work and finish what they started. So, some customers won't even go back to the shop that did the work if something's not right. You ever seen that? Somebody goes to a shop and they charge $500-600 to fix whatever it was. And so they didn't like that work, so they take it to a different shop, and a different shop charges them another $300-400, and it still ain't fixed. And then it's he said, she said. Something they did, something they did, something they did. The best, smartest thing something a customer can do is go back to the same shop and say, look, I paid you $500-600, I want this fixed right now. Not always fair to the shop that did the work to begin with, because sometimes hidden problems emerge, okay? First shop might have been happy to fix it if they had the chance. Now, here's a phone call. She and her husband paid a local shop $1,500 to install a salvage yard engine because the original engine had developed an engine knock. How do you find an engine knock and which cylinder it's on? If it's like a rod. You got any idea? Kill the cylinders one at a time. The one that stops knocking, that's the one. Okay? It ain't too bad. I got a video on that. After the job was done, the bill was paid, the car didn't run as well as it had before the previous engine started locking. You know, it's running worse. It wasn't knocking, but it was running worse. So she wanted us to check it out rather than taking it back and install the engine, not sure why. So she described the problem as a vibration, and I started thinking of a driveline or wheel balance. That's what somebody says vibration, that's what you're thinking, driveline, wheel balance, you know, bad tire, something like that. The customers always describe their problem well. Incidentally, welders don't know how to do this, right? Okay, when we finally spoke face to face, she was filling out the paperwork. The vibration was happening when the car was sitting still, not when it was going down the road. Check the engine. The idle vibration is pretty excessive. And in a healthy 2-liter platform, if it doesn't have a balance shaft in it, since how many firing events are there? How many degrees are there between firing events on a 4-cylinder engine? We already covered this once. You guys are supposed to burn it in, remember it. How do you tell? In other words, how many degrees is that crankshaft going to turn as the cylinder number 1 fires? How many degrees is the crankshaft going to turn before cylinder number 2? 180. Because if it's firing, if through the engine, over 4-cylinder engine is trying to jump up and down all the time anyway. See what I'm saying? So you're going to feel that. And some of these cars, old Ford Contours, had a little bit of a quiver in the steering wheel and all that stuff. But they did all kind of, you know, Ford came out with this thing about replacing the radiator mounts and putting dampers in the steering column shaft and all kinds of stuff. We've got to fix it where the customer wouldn't feel it. Well, a lot of them went ahead and put a balance shaft on it so that it had a weight pulling down when the engine was trying to jump up, and it would just smooth it right out, you know. But this one didn't have one. Well, the mill loan, I didn't remember her mentioning that. She didn't say about the check engine light. So before we did the highway test, we plugged in the NGS, had a quick look at what was stashed in the memory. The P codes showed the fuel control system had reached the maximum compensation for both lean and rich. It's telling us I have gone as lean as I can go, and I have gone as rich as I can go. And it was responding to oxygen sensor input. The oxygen sensor had gone lean, and it had gone rich to try to compensate. And then the oxygen sensor had gone the other way. And sometimes that means the oxygen sensor is flatlining, and the fuel trims go way up, try to pull it back up. And then while that long fuel trim's up there, the oxygen sensor comes back alive. And then they says, oh no, now we got too much fuel. And then it goes back the other way. See what I'm saying? So that's just, I mean, and the short fuel trims will react suddenly, and then the long fuel trim follow a long time. Well, a combination of codes sounds peculiar. I've seen this little syndrome before. All right, so anyway, so what we got here, rich problem or lean problem. One possible cause we're concerned is an oxygen sensor that drops offline long enough. This is what I was talking about. Fuel trim goes positive, O2 flatline, fuel trim way up into the 20s. If the short fuel trim stays there long enough for the long fuel trim to follow its more sensitive little brother, then basically that's what goes on there. See, here's your fuel trim, adding and subtracting. See, if the fuel starts going this way because the oxygen sensor is seeing air, it's going to start pulling in the other direction. We've talked about that in our fuel trim stuff. And so let's go on over here. Let's do this right here. The Mazda wasn't running right. The idle was way too rough. Had a quick peek into the data stream, numbers that were anything but proper. We had to do it around the minus 25 mark, and that means what? If it's at the minus 25 mark, what does that mean?
It is tooling, right? Rust tooling.
Rich, and it's trying to pull it lean. If it's minus, if it's subtracting, it's going the opposite way. You see what I'm saying? Everything else looked fairly normal with the exception of a mass airflow voltage that seemed a little bit too high idling. So, ordinarily, mass airflow voltage at idle on these platforms running the 0.7 to 10 volt area if you're looking at voltage. But this mass airflow is reading nearly 1.2 volts. Now, most of the mass airflow readings that you read on modern vehicles is reading in grams per second, and I really like that. And typically, your rule of thumb is when it's idling, if it's a 4-liter engine, it's going to be somewhere around 4 grams per second. You got that? They actually, on some of them, they'll break it down and give you even more evolution than that. You know, I mean, but 4 grams per second is what I expect on a 4-liter. If it's a V6, I mean, it's a V8, you know, if it's a 5.3, about 5. That's rough. It's going to be a little higher if the idle air control's kicked up or, you know, something else going on. But checking the idle air bleed screw on the throttle body, which lets air go around the throttle plate so you can adjust that. We discovered it had been backed almost all the way out. Somebody was trying to smooth the idle by giving it a little more speed. Make it idle up a little higher, what they do on that. So after running the throttle body Y idle and setting it back to its normal position, which is 650 to 750 with the idle air control valve disconnected and the coolant fan not running, we still weren't satisfied with the idle quality, let alone the scan tool readings. Mass airflow still seemed a little bit high, but we opted for a highway test drive. Now, it ran a lot like it had a crack in the air inlet tube that would get wider with torque, but the problem only seemed to occur at about 3/4 throttle. If Jimmy pushed his foot past the 3/4 point, the car would hunker down like it was starving for fuel. Like that. You let off to that 3/4 point and it feel like it's pretty good. You know what I'm down? Alright, so most Chrysler products use mount rather than mass airflow. We talked about that before. Right at a 3/4 throttle level, it would buck and jump. And below that, apart from rough idle, ran normally, a little weak on the takeoff. The TP voltage was sweeping smooth, which is what we were looking at, all the way from 0.5 to about 4.6 at wide open throttle, but the O2 would go lean, even though the PCM should have been delivering full enrichment at that load and throttle angle. See, open loop is when it's not paying attention to the oxygen sensor. That's when the engine's cold or when you're at wide open throttle and you don't want it jacking around with the gas while you're going up a hill passing a semi. Although if you're doing that, you got rocks in your head anyway because a car can come over the hill and take you out. Okay, you ever seen somebody do that? Pass a car and you're thinking, man, if somebody comes over a hill, they're toast, you know, and they manage to get away with it just time and time again. Like looking at that. What do you think, Jimmy? We encountered an opportunity for a rapid learning curve. He was eager. I think we need to check the fuel pressure. Made sense, right? If you had fuel pressure that was dropping off because it was starving for fuel because of a kinked fuel line or a plugged up fuel filter, you have issues with that. So underload stall out problem. There we go. All right, here's our Mac Tools gauge that we got on there. On this particular one, we had to take a little banjo fitting loose. We had to put a fitting in there and then we couldn't snap this onto that. And, well, he's making a lot of noise out there. Unless this gauge was reading air or water pressure, which it turned out it wasn't, this number looked pretty good. This is at wide open throttle. We got 45 pounds of fuel pressure. Didn't drop off. Now, if you go into it really, really deep and the fuel pressure drops off when you do, you got a weak pump, clogged up filter cart or your filter. Fuel pressure data under our belt. Let's look at wide open throttle. We look at our window into the system, which is our scan tool. We reiterated the discovery that each O2 sensor will read lean. Short fuel trim was at 33, and the mass airflow was reading only 2.78. See that? Mass airflow, 2.78. And that was LBM. What do you think that is? I don't worry about it. This is what I'm worried about right here. Oxygen sensor is, see how these been moving with lean? Short fuel trim is up to 33% because everything's going lean and it's trying to pull it. All right, TP mode's wide open throttle, TP volt's 4.29. This is the pertinent PIDs, right? Now, if you pick fewer PIDs, you get faster updates. If you're looking at every darn thing in the system, it's going to update slowly enough where you may miss them. The mass airflow was incapable of reading more than 2.78, even though the airflow was beyond that. Notice the flat-lined O2 signals and a strong positive fuel trim number. It believed it could trust the mass airflow because the signal was responding to perceived throttle angle changes and PCM-driven IEC adjustments. You see, the PCM can make rationality checks. It can watch the mass airflow, and it raises the idle air control, and it watches it go up. When the throttle position goes up, it expects mass airflow to go up. If you drew those on a graph, throttle position and mass airflow is going to track, right? Boom, boom, boom. Y'all see me do that on the scope out there, I think. A lot of y'all have. You hook up mass airflow, you hook up throttle position, you give it the gas, and they go together. If I put two markers on the board, they'd be drawing together for mass airflow and that. All right, this is the red flag right here. Smoking gun. Notice the difference between the mass airflow numbers. With the throttle wide, as before, it was steadily climbing through its gears, increasing road speed. Wasn't stalling out at 50, kept on going up. Look where your oxygen sensors were. Almost up at the top of their range. Right there, close to the gun. Short fuel trim is basically going to be, that's 30%, but that's okay because that's where it's supposed to be when you're at wide open throttle. Open loop, adding some fuel. TP voltage, right there. All right. So anybody that studies and looks at normal readings, you want to get good at reading a scan tool, plug a scan tool into every car that you can that's running like it's supposed to, and look at those readings and get used to what they're supposed to be. As a matter of fact, when you're doing automatic transmissions, if you put an automatic transmission pressure gauge on your own vehicle and drive it around for about a week and watch what those pressures do, make you a whole lot better troubleshooter on automatic transmission when you're doing pressure tests, right? All right, so usually figure out an ordinary set of signals and find the source of concern in short order. Treasury agents, well, Secret Service agents. The Secret Service is actually the original reason that they were convened was to stop counterfeiters. And what they do is when they want to be able to look at money and be able to recognize it as funny money, do they study funny money? They stole real money. You get to let real money good enough, you know instantly when you see a phony bill. Instantly. So if you look at, this is like that. If you're looking at good readings all the time and all of a sudden you see one that's out of line with those good ones, beep, 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 beep. Let's plug every normal car you can together. So understanding the nuances of this system, what we did was we unplugged it and it ran great. Now that's not the first time I've ever seen that. Not the last time I've ever seen it. Whenever everything's running just perfect right up to a certain mass airflow voltage, and it stops right there because that's all it's reading. See, if that's what the engine controller is trying to trust is a mass airflow. That was an in-range failure. That's what I'm talking about. It never got out of range, but it stopped telling the truth when it hit that 2.7. It hit a ceiling that was lower than what was true. All right. PCM makes comparison. That's what I was talking about earlier. It commands an IEC percentage increase. It doesn't reflect the increased airflow. The RPM doesn't increase. The PCM got the idea the IEC is not operating. That's a rationality check is what they call that. Well, PCM can't detect an electrical concern but doesn't see the expected physical change. They call that a performance code. Like, for example, if it knows a particular solenoid has got good electrical continuity all the way through it, see, when it doesn't have that solenoid grounded, power is feeding the other side of the solenoid, it looks for voltage coming in, and if it grounds that and that voltage goes away, and if it ungrounds it, the voltage comes back, it knows electrically it's okay, but it also knows that whatever that solenoid was supposed to do didn't happen. That's a performance code. So basically, a transmission solenoid. I turned on this solenoid, it should have shifted gears, and it didn't. So that's basically a performance code. Now, we can think the same way when you understand the system. Here's your test question. Technician A says, most mass airflow sensors also report barometric pressure to the PCM. Technician B says, a baro reading that indicates a high altitude will cause an engine to run lean. Who's correct? You got 10 seconds. 9, 8, 7, 6. Everybody done? Best way to determine if a given mass airflow sensor reading is acceptable is to do what? Compare it to shop manual specifications. Good luck with that, right? Measure the hertz or voltage at the sensor connector. Watch the fuel trim readings while choking off air to the sensor. Compare the reading to a known good sensor on the same vehicle. Technician A says a mass airflow sensor graph should mirror TP voltage and a mass airflow reading should go down when TP voltage goes up. In other words, that would be, mirror would be opposite directions. Technician B says engine vacuum usually goes up as soon as the mass airflow reading increases. Technician A says most PCMs routinely perform rationality checks by using certain sensor readings to determine the efficacy of a related output actuator. Technician B says continuous codes virtually always point to a particular sensor. Who's correct? Which of the following is least likely to be the cause of an induction backfire? That's when it's going through the intake. Boom, boom. You know, when it backfires through the intake and smoke comes out the air breather. Main exhaust, bad mass airflow, cross plug wires, faulty downstream O2 sensor. This is which one is least likely to be the cause of an induction backfire. This is like an ASC question. Sometimes they'll say except, least likely, this kind of thing. They'll want to make sure that you got a heads up on that. O2 sensor values that read lean on hard acceleration are caused by, may be caused by rather, uncommanded EGR flow, stuck closed fuel pressure regulator or pinched return line, excessive voltage drop in the fuel pump circuit, or none of the above. If I'm going too fast for you, don't worry, it's all in electitude. A misfiring cylinder due to a foul spark plug can cause a lean O2 signal in higher fuel trims, a rich O2 signal in lower fuel trims. An injector that doesn't operate on a misfiring cylinder are both A and C. Technician A says a faulty mass airflow sensor may cause poor fuel economy on a Dodge Caravan. Technician B says a split air inlet hose between the mass airflow sensor and throttle body can cause a Dodge Spirit to exhibit a rolling idle and a surge on acceleration. The 2001 Monte Carlo is being checked for power loss under acceleration. Technician A has checked the fuel pressure in the service bay and says the problem has to be somewhere else because the fuel pressure is fine and within specs. Technician B says the fuel pressure should be monitored while the car is being driven. Who's right about that? Technician A says the idle air bleed screw can be used to adjust mass airflow voltage in order to offset a lean condition. Technician B says the mass airflow voltage should increase and idle air control increases. And we back up and see how you did. All right, what do you think? Technician A right? Is Technician A right? You nodding your head?
Yeah.
He's right. Technician B says barrel reading indicates a high altitude will make it run lean, and it will. If the barometric pressure reading is 4,000 feet, not as much air, it's going to put not as much fuel, it's going to read lean. If it's using that for a priority signal. Speed density systems like the ones that don't have mass airflow sensors have a trouble with this for sure. Best way to determine if a given mass airflow sensor reading is acceptable is to compare the reading to a known good sensor on the same vehicle. That's the smartest way to do that. Because those shop manual specifications are like way out here, you know, they're real wide. Technician A says a mass airflow sensor graph should mirror TP voltage. That's totally wrong. It ought to follow it, not mirror it, okay? Technician B says engine vacuum generally goes up as soon as the mass airflow reading increases. Engine vacuum actually goes down. If you open the throttle, mass airflow goes up, your vacuum's going to go down, pressure in the manifold's going to go up. Vacuum and pressure are seesaw. The more vacuum you got, the less pressure you got, and vice versa. Right? Okay, so vacuum goes up. Both those guys are wrong. Technician A says most PCMs routinely perform rationality checks. That's right. Technician B says continuous codes virtually always point to a particular sensor. When it says always, that's a red flag. So technician A is right, B is wrong. which of the following is least likely to cause a backfire? Faulty downstream O2 sensor. Not likely to have that, you know, not typically. Cross plug wires will, that's all enough to backfire. Bad mass airflow sensor cause lean exhaust mixture. All three of those can cause it. We used to have a little 91 S10 trainer vehicle around here that had throttle body injection on it. If the spark plugs were dirty on that thing, even if everything else was right, it would backfire through the throttle body and blow fire that high. Make you think it's out of time. If you have your head over it, have you ever had your hair singed? You smell it for several days in the shower. I mean, it doesn't ever go like that. All right, O2 sensor values that run lean on hard acceleration may be caused by what? If a stuck closed fuel pressure regulator, you're going to have high fuel pressure, right? That's going to be too much fuel. Uncommanded EGR flow, I don't think so. Excessive voltage drop in a fuel pump circuit, that's possible. Because the fuel pump running slower, you ain't going to have as much fuel, and it's going to make it run lean, correct? Now, some systems used to have a ballast resistor in the line feeding the fuel pump because they wanted the fuel pump not to run so fast because they didn't want it to be loud. They didn't want a customer listening going down the road. And they used to do that, you know, but after a while they decided it wasn't a big deal, all that went away. Misfire in cylinder due to a foul spark plug. What do you think? Somebody give me an answer. What'd you put? Huh? Delta? Yeah, that's right. So if you got a misfire in cylinder due to a foul plug, you're going to have oxygen in there. What's the oxygen sensor smelling? It's smelling oxygen. It couldn't care less about fuel. It's just smelling air. Okay, and so that's what you're going to get. You've got higher fuel trim because it's getting more air. And if that happens, you're going to have other issues too. A says a faulty mass airflow sensor may cause poor fuel economy on a Dodge Caravan. Neither one of those cars has mass airflow on them. Got that? All right, so that's neither. 2001 Monte Carlo for power loss under acceleration. Check the fuel pressure in the service bay. If you're just looking at it in the service bay, you ain't gonna know nothing, are you? You better get out there while it's giving a problem and check it that way. And so B is right on that one. And A says the air bleed screw could be set in. Just most vehicles now don't even have an idle air bleed screw. That Mazda did, but most of them don't have one. It's a little screw that just usually got a little plug over it. And you pop that plug out, you can turn it, you know, feather that throttle. Not supposed to do that. Here's something else that's spooky. If you're doing some kind of an adjustment on the emission system that's not in the shop manual, and an EPA guy happens in, and they say, "What are you doing?" You'll say, "Well, I'm setting this idle air bleed." If that's not in the shop manual, $10,000 fine. I mean, you never hear of that, but it can happen. See, if you're doing something that's not in the shop manual, you can get hot water with the EPA people. You know, just like I'm always telling y'all guys, there's some things you don't do. You don't modify an airbag system, and you don't modify cruise control. Don't do something dicey to try to make it work, because if something happens, then it's on be on you if you didn't put it back like the manufacturer said, right? All right, so should the mass airflow voltage increase as idle speed control increases? It should. Right? So this one right here is something you're really not supposed to do, so we're going to say B is right one on that one. Okay, you got that? All right. Now I'm going to show you guys a couple of things.